Alright, and now we have reached problem 7 of the final exam review guide, which reads, a proton, or in parentheses, a proton mass is equal to 1.67 times 10 to the negative 22nd kilograms, is moving with the speed of 3.0 times 10 to the 6th meters per second, and enters a uniform magnetic field and travels in a circle of radius 0.20 meters as shown in the diagram below. That's this diagram here. And first it asks, what is the centripetal force of the on the proton, sorry. Alright. So for this, first we need to establish centripetal force, which we know Fc is equal to m, the mass, times v, the velocity squared, all over r, the radius. And all of these things are given in the problem. And so it's a fairly simple, thing to do to plug in all of our numbers. And so we can say that Fc is equal to the mass of the proton, which is 1.67 times 10 to the negative 27th kilograms, times the velocity, which was given to us as 3.0 times 10 to the 6th meters per second, and that velocity is squared, and all of that over the radius of our circle, which is 0.20 meters. Now we just plug that into our calculator here. So we have 1.67 times 10 to the negative 27th times, in parentheses, 3.0 times 10 to the 6th, in parentheses, squared, and then all of that divided by 0.2, which gives us 7.5 times 10 to the negative 14th. Oh, and that is going to be newtons. Don't forget your units. And so that will be our answer to part A of that problem. Part B asks what is the magnetic force on the proton. And so it might be helpful to be able to see this here, since this is more of an explanation. But the magnetic force is going to be the magnetic force on the proton is going to be the same as the centripetal force on the proton, since there's only one force that's acting on this proton, unless you count the force of gravity, which is close to negligible. And so we're going to say that the magnetic force, or Fm, is equal to Fc, the centripetal force, which we just solved for up here, 7.5 times 10 to the negative 14th newtons. And so that will be our answer to part B. Alright. Another way you can probably think about this is if this were a wire here, and using partially our right-hand rule and then partially our definition of what causes forces or causes the magnetic force, you could say that as the proton moves that way around a chord or is in the circle, that the magnetic force would point towards the center the same way that the centripetal force does, away, the same way as the centripetal force does, which is partial proof about why they are equal to each other. Alright, part C, we have to determine the strength of the magnetic field. And the magnetic field is defined by variable B, as seen in this equation up here. Fm is equal to Q, the charge, times V, the velocity, times B. And so we have Fm, which we just solved for here, 7.5 times 10 to the negative 14th n. That is equal to Q, which is the charge of a proton, as seen right here, 1.60 times 10 to the negative 19th coulombs, times the velocity given in the problem as 3.0 times 10 to the 6th meters per second, times B, which is what we are solving for. So now we can plug that into our calculator here. We have 7.5 times 10 to the, we can just use this again. Alright, and that's going to be divided by 1.60 times 10 to the, negative 19th times 3.0 times 10 to the 6th. And, oh my! I typed that in wrong. Alright, let's try this again. Alright, so 10 to the negative 19th times 3.0 times 10 to the 6th. That's better. All right, and we are going to get 0.15656 blah blah blah. Round that to 0.16. All right. And that, oh, these are Teslas, by the way. Magnetic force is in, or magnetic field strength is in Teslas. So we have 0.16 T for Tesla. And this will be our answer to part C. This was part B, by the way. All right. Now we're moving on to part D, which says to sketch the direction of the magnetic field in the diagram below. And so I'm just going to draw this really quickly over here. This is 0.2 meters, and then there's that, and then this is our proton. And the proton is moving upwards here, like that. All right, so this is a job for the right-hand rule. And so if you remember, we have our 3 fingers. We have our thumb, our pointer finger, and our middle finger, which forms an XYZ sort of coordinate plane with our hand. And we know that V, our pointer finger, or our pointer finger represents V, the velocity. Our thumb represents the magnetic force in newtons, and then our middle finger, not flipping anybody off, is equal to the strength of the magnetic field. And so we know from this diagram, since we're solving for where the proton is, we can see that the velocity is forward, since the proton is moving in this direction as indicated by the picture. Well, I'm gonna just put the real picture here, that'll probably help. So we have the proton moving forward here. We have velocity moving forward. We also know that our magnetic force will be pointing inwards, like this, and so we have an L, basically. And since we're using our right-hand rule, and we know that the magnetic field has to be pointing in the 3rd direction, we have the velocity upward, we have the magnetic force pointing sideways, or to the left, west, whatever you want to call it. And so that means that we have our magnetic field strength pointing into the page. And so our answer to part D here will be into the page. And so I did realize I misspoke earlier when I was trying to explain the forces here. The magnetic force is going to be pointing towards the center since the proton is moving around in a circle, as opposed to centripetal force, which is, you know, pointing. Centripetal force are pointing inward too. What am I saying? I don't know what I'm doing. I'm sorry I'm confusing you. They both point inwards. That's why magnetic force points inwards. Yay. All right, right-hand rule. Oh, before I go, showing you the answers here. Answers to problem 7. I hope this is big enough to read. Woo! All right, hopefully that is. Answers to problem 7, 7.5 times 10 to the negative 14th newtons, 7.5 times 10 to the negative 14th newtons, and 0.16 Tesla. If you check on the classroom site, it also tells you that the correct answer is into the page. It has that in the solutions, and then also in a comment that Mr. Headley put there. It's not printed here, but the correct answer is into the page, just for assurance's sake. So thank you for the final exam review problem explanations, or thank you for listening to them, joining me. You can subscribe to this on YouTube if you'd like. You don't have to. I'm not going to make you, but thank you.